This is problem 7 from one of the WebWork homeworks. You'll recognize it, I think. 75 numbers are to be rounded off to the nearest integer and then they're added up, and you're worried about how the difference between the rounded sum compares to the sum of the original numbers, and you're interested in this case in the probability that the rounded sum is differs from the exact sum by more than 5. So here's the things that we're going to need to understand on this one. A uniform distribution looks like this. When you look at that rounding, if you look at any particular number and look at the fractional part of that number, it's going to be somewhere between, when you round off, you're either going to be subtracting no more than 0.5 and you're going to be adding no more than 0.5. And they told us that the rounding part was uniformly distributed, so there's equally likelihood of any one of those numbers being chosen. We're going to take a sample of 75, and we know that from the central limit theorem that even though this is not normally distributed, the distribution of the sample means will be uniformly distributed. So we look at all of these fractional parts, and we round them. So we're going to divide by 75, and we're interested in that rounded amount being less than -5 divided by 75. That would mean that the sum of all the rounding would be less than -5, or greater than 5 divided by 75. That would be the other average. We know from the central limit theorem that the mean of this distribution of sample means will be the same as the mean of this distribution. And here's the trick in this problem. Some of you successfully did this, as a matter of fact. You went and found somewhere that the standard deviation, the variance and standard deviation of this uniform distribution, the standard deviation is going to be 1 divided by the square root of 12. So that means by the central limit theorem that the standard distribution of the sample means will be 1 divided by 12 divided by the square root of this sample size. So it's going to be that particular amount. So we need to find the area of this red area, because those would be all where the averages are less than -5 divided by 75 or greater than 5 divided by 75. And in either one of those cases, the sum of the rounding, the difference between the two sums, would be 5 or greater. So here's what we're going to do. We're just going to use this normal distribution. So I'm looking for the probability of a normal distribution. I'm going to 2 times it because we're centered at 0, so this red part to the left is exactly the same as the red part to the right. I'm interested in the probability less than -5 divided by 75. The mean is 0 and the standard deviation is this amount. All of that was dependent on this standard deviation that we had to look up somewhere. When we do this calculation, then we get that particular amount, which is the correct answer.